Yes, hello guys. We are discussing about partial differentiation, and this is the second exercise, second lecture based on partial differentiation. And the similar type of differentiation as I discussed yesterday before starting this question, that this is just type of general differentiation. Okay, in general differentiation we consider constant as constant, but here we consider the independent variables as well as as constants. Constants are constant always, but even in this case, independent variables are considered constant when we are differentiating with respect to one independent variable. Okay, then other independent variables are considered constant. This is the basic difference of partial differentiation. Now, the 11th question and 12th questions are left over. So let me discuss about these two questions. Okay, so this question, this is 11th one. This question, I think there is one correction here. Let me tell you about what is correction. This we have to, if u is equal to 1 minus 2xy plus y square whole power minus half. Okay, this is first equation we have considered. Then to prove here that del x of this is 1 minus x whole square. But I'm sorry, this is not 1 minus x whole square, but it is 1 minus x square. This is a correction, a bit correction here. Okay, this is a bit correction here. This is 1 minus x square, not 1 minus x whole square. Okay, this is a bit correction here. Let me write it here also. Okay, there is a bit correction here. Bit correction is that this is 1 minus x square, not 1 minus x whole square. Okay, this is 1 minus x square into del u del x. We have to prove here that del x of 1 minus x square in bracket del into del u del x bracket close plus del y of y square del u del y equal to 0. This we have to prove. Okay. For that, let me differentiate the first equation. Why? Because we require here del u del x and del u del y first, and then we do whatever the resultant will be here after multiplication of 1 minus x square in del u del x. That is to be further differentiated with respect to x. Similarly here, after multiplying y square with del u del y, the result of del u del y, then we again differentiate with respect to y. Okay, so in second derivative we have to find out here. Then we have to prove that this is the given. Now let me take differentiating first equation. Differentiating first with respect to x partially. This is partial differentiation, undoubtedly. Okay, partially keeping y constant. Keeping y constant. This is partial differentiation, so it is obvious that when we are differentiating with respect to one independent variable and other variables other variable or variables are considered as constant or kept as constant. So let me differentiate the first one. This is del u del x. Differentiating with respect to x here. U is del u del x. This is simply minus half power will come before minus half. 1 minus twice xy plus y square whole power minus 3 by 2. Why? So minus half minus 1 means minus 1 and a half. Okay, minus 1 and minus half, that means minus 3 by 2. Okay, for 1. But still, the differentiation is not complete because this bracket value is not x simple x. Whatever x factor is there, that is to be differentiated again. If y square will be 0, 1 will be 0 because they are constant, as considered constant. Now twice xy will be minus twice y only. Why? Because x is 1 and minus 2 into y is in multiplication. This is minus twice y only. Okay, so this 2 cancel out. Minus plus. This is nothing but y upon, take this to denominator. So 1 minus twice xy plus y square whole power 3 by 2. This is, let me take value of del u del x. This is first, second equation I have taken. Now if I find out del u del y, differentiate, then differentiating first with respect to y partially, okay, partially keeping x as constant, keeping x as constant, considering x constant. Okay. Now differentiating same first function. This is del u del y is equal to again minus half. Power will come before, then leftover power will be this is plus y square whole power minus 3y2 y minus half minus 1, that means minus 3y2. This is minus 3y2 power. Again differentiating the bracket value with respect to y. This y is 1 minus twice x into by 1 plus y square is twice y. This is with respect to y we are differentiating. So after differentiation with respect to y, we have obtained this value of the bracket minus twice x here, y is 1 plus y square is twice y. Okay. So here 2 to cancel out, let me divide it by 2. 2 and 2 cancel out. Minus sign let me take inside. It will be plus x minus y. This is x minus y plus x minus y. But minus after multiplying by minus sign, it will be plus, it will be minus x minus y upon 1 minus twice x y plus y square. Taking this in denominator, because negative power is there, it is positive 3/2 in the denominator. So this is value of del u del y. So let me take third equation. Okay, so values of del u del x and del u del y are obtained. Now let me take the after multiplying 1 minus x square del u del x and y square del u del y. What do we obtain here? Now let me write here and here also. This implies that 1 minus x square, this is 1 minus x square, not 1 minus x whole square. Initially it was 1 minus x square, 1 minus x whole square. This is given by the students, but I'm sorry, this is wrong. Please note down, this is not 1 minus x whole square, it is 1 minus x square. Keep this in mind, only then this value is proved. Otherwise, one cannot solve that. Okay, one answer is not obtained. So that we have calculated number of times, and after that this was given by the students, but question was wrong here. The multiplication is with 1 minus x square, not 1 minus x whole square. Keep in mind, please. So therefore, 1 minus x square into this bracket value del u del x, it will be multiplied by 1 minus x square. It will be 1 minus x square into y. This one divided by 1 minus twice x y plus y square whole 3/2 power. Okay, so this is to be now kept here, then value del x. Let me write here. Okay, so let me write it here. So this we obtained del x within bracket this value 1 minus x square into y divided by this 1 minus twice xy minus twice xy plus y square whole power 3/2. Now this is to be differentiated further with respect to x here, because this value was of 1 minus x square into del u del x. This value, okay, this we have kept here. Now plus sign del y of y square into this value, because this is value of del u del y. Y square into this means x into y square in the numerator minus y cube, because y square into y minus y is y cube divided by the same value 1 minus twice x y plus y square whole power 3/2. This is now this is left hand side here. We have to prove that this is equal to, this is left hand side. Left hand side we are taking all this proof here. Okay, this is the left hand side. Now let me differentiate each part of this. Okay, both the parts if are differentiated. Now let me check whether it is equal to 0 or not. Okay, that is one of the points here. Let me differentiate this. So this is numerator upon denominator, but it includes x here, it includes y here, so both will be different by quotient rule. But the quotient rule, denominator as it is, let me write here. This is 1 minus twice xy, this plus y square whole power 3 by 2 as it is. Differentiation of this. What is the differentiation of this? So this is multiplied by y, but only x square will be different. 1 is 0. If I differentiate this bracket with respect to x, then 1 is 0, minus twice x into y. This is minus twice x into y only. Because y, if it is y minus y x square, y is 0, differential with respect to x. Minus sign in between quotient rule. Okay, so this is to be differentiated, but this value y minus y into x square kept as it is, numerator as it is, denominator differentiation. Then differential denominator will be 3 by 2. Let me write here 3 upon 2 into, this is the multiplication, 3 upon 2 into 1 minus twice xy plus y square whole power. Now 3 by 2 minus 1 is 1.2. Why? Because 3 by 2 minus 1. This will be the power now. 3 minus 2 upon 2, that means 1.2. 1.2 power. Oh, this is the 1.5 power minus 1, that means 1.5 power is left. That is obvious here. This I solve this. The power is left this, but still it will not complete. The bracket value is to be differentiated with respect to x. Here it is minus twice y only. 1 is 0, y square is 0. Only minus twice y. Why? Differentiating with respect to x. X is 1, minus twice y is multiplied. This is minus twice y. Alright, okay, we have got this. This is 2 and 2 cancel out. This minus sign is plus sign. Plus y into this whole value. Okay, so let me write it again. Divided by with the denominator. Denominator is whole square of this value. This value, whole square will be 1 minus twice xy plus y square. Whole square means y is multiplied 2 to cancel out, this power 3 only. I'm taking this first part here. Part first, this part second I'll take later, then I'll add them. Let me take the first part here. First part is equal to this. Okay, this is the part first, this is part second. Part first I'm doing first. Now let me solve the numerator here. What is common here? This is the same value. Okay. So this half power is common. Then here 1 power will left over. This half power will come out. That is 1 minus, let me take common, 1 minus twice xy plus y square whole power half, or square root of this is common in the numerator. Okay, in the numerator, this value, so 1 is left, 1 power is left. That means 1 minus twice xy. This y square is left, this minus twice xy. See within bracket minus twice xy. Okay. Now here this minus sign is plus sign. Plus 3 into y. If I multiply this by y, that will be 3 into y square. Now this is y into x square. Divided by this value 1 minus twice xy plus y square whole power 3 over 3. Okay, so this is first part we are solving. Let me further multiply and check whether something is cancelled out. Here this power will come in the denominator. 3 minus half means 5 and 5 by 2, that means 2 and half left over. If half is subtracted from this, so we will have 2 and half over. So let me solve this. Minus twice xy into 1, that means minus twice xy. Minus twice xy into this is plus 4 x square y square. This is 4x square y square. 4x square into y square. minus minus plus plus 4 x square y square, right? Minus sign twice y cube, so this is x into y cube. Okay, now this is plus 3y square, and this is minus 3 x square y square. Okay, divided by this is 1 minus twice xy plus y square whole power 5 by 2 now. For this power taken in the denominator, half power be subtracted from 3. 3 minus half is 2 and half, that is 5 by 2. Okay, this first part we are solving. This is part 1. This part 1. Okay, so we are solving this. This is equal to how much? Any similar terms, like terms? Minus twice xy, no similar terms. This is the unique 4x square y square. This is plus 3x square y square. This is plus x square y square. 1 is left here. Okay, this is 4x square y square is minus 3x square y square is plus 4. So only one positive value, x square y square is left. Now this is common. This is plus 3y square. Let me write here 3y square, and this is minus twice x y only. This we have already taken with this. Okay, so these two are combined, others are different terms. So this is divided by 1 minus twice x by y square whole power 5 by 2. Now let me write it here in place of this. So this whole I have done. Let me write it here in place of this, and second part I have to do. So part 1 in place of this whole is this value. This is minus twice x by plus x square y square. Let me take first x term. This is minus twice x y cube plus 3y square. This is 3y square. This one is minus twice x y cube plus x square y square. Okay. Divided by 1 minus twice x y plus y square whole power 5 by 2. This is part 1. Now plus this value is to be calculated. Let me calculate this. Is to be calculated. Now let me take second part. Now this is again quotient to second part here. If we write here second part, and I'll write here, then we will solve them. So this is second part. I'm solving part second here. So this part second. So this is del del u. So del del by of x y square minus y cube divided by 1 minus twice x y plus y square whole power 3 by 2. This is to be differentiated as quotient rule, taking this as a quotient rule, applying quotient rule. I mean, so numerator differentiated, denominator as it is. Denominator is 1 minus twice x y plus y square whole power 3 by 2, the same as it is. Now numerator is differentiated with respect to y here. This is twice xy. First is twice xy minus and 3y square. We are differentiating with respect to y. So y cube is 3y square, and y square is twice y. So this is multiplied by x, twice xy. Okay. This is the value. First part minus sign. Now this value is same numerator as it is. That means xy square minus y cube as it is. Differentiation of denominator. That means again let me take 3 by 2 into 1 minus twice xy plus y square whole power half left over power 3 by 2 before, 3 by 2 minus 1 new power now. That means 1 upon 2 only. 3 by 2 minus 1 is 1 upon 2 into multiplied by differentiation of this with respect to y here. With respect to y, which is minus twice x. First term y is 1. This is minus twice x. Plus y square, 1 is 0, so we are not taking 1 here, but twice 1 multiplied, okay, and divided by, again this is 1 minus twice xy plus square whole power 3 by 2. So this is 3 by 2 into square, that is 3 over 2. This is we are doing this. This is part 1 we are solving. Now let me further solve it. Now 2, if I divide by 2, this 2 and 2 cancel. Take a 2 common from this and this 2 divided, so 2 cancel out. And okay, so let me take common here, the second part. Now this is 3 by 2 power, this is half power. Half power is again common. 1 minus twice xy plus y square whole power half common. Throughout common out of these two terms. So here we are left with 1 minus twice xy plus y square, 1 power is left. Because after 3 by 2 minus half, 1 will left. So this is 1 power is left. Twice xy minus 3 into y square in the second bracket. This is there. Same bracket. This is the 1 power left, power 1. Okay, so these two terms are here. Now from this 3 into this, and this is y minus x, that we take, or if I take plus sign here, this is plus sign minus, this minus sign will be positive, that means x minus 3 into this 3 are taken here, 3 into x minus y, this is x positive, y will be negative after minus sign, multiplied by minus sign in one bracket, and other value, this one we have taken out. Okay, so this is also there, this one, which is x into y square minus y. To get this value, which is here, that is same, this is our numerator here, numerator as it is, this value has taken common, this whole power half will come out here, this is there, only these two are left over, and this 3, so 3 into x minus y, because this with minus sign multiplying, this is positive sign now. Okay, so this is whole value divided by this 1 minus twice xy plus sign y square whole power 3. Now this half power, let me take here 3 minus half, this will be removed because this are taken here with minus sign, same power, same value. This will be, now numerator let me solve. Twice xy, if I multiply by twice xy to these 3 terms, let me multiply that. What do we get? This will be, let me write here, twice xy positive plus sign, this will be 1 into twice xy. Now twice xy into this is minus 4 x square y square minus 4 x square y square, twice xy into y square, that means plus sign twice x y cube. Okay, now with the minus 3y square into this 3 parts, this will be minus 3y square into 1 means minus 3y square minus plus, that means 6, 3 to the 6, this is x into y cube, 3 into 3 to the 6 plus 6 x as it is into y cube. Alright, this is done. These are the 6 terms, 1, 2, 3, 4, 1, 2, 3, one more is there. This is now 3y square minus 3y square into y square, that means minus 3 into y 4 power, y square into y square is y 4 power, and 3 minus 3. Okay, now we have 6 terms here, 1, 2, 3, multiplied to this one term, 3 terms, and this second term, 3 terms more, we have total 6 terms. From this, there will be 4 only, 4 parts. This 3, let me take, multiply to 3x to these 2, so that will be plus 3x square into y square, is x into x, that means x square into y square, but 3 so multiply, 3 multiply. Okay, now this 3 into minus y, sorry, this 3 into x to this will be minus 3x minus 3x into y cube, that is there. Okay, now by minus 3y into x minus 3 into minus y, that is x into x as it is, but this 3 minus 3y into y square, that means 3y cube y into y square. So this minus and minus plus sign 3y4 is a 3y4 here. Okay, so minus 3 by 4. Okay, this is complete now. So there are 4 terms here. 1, 2, 3, 4. After 3 into multiplied, or first let me multiply by x, will be x square y square, then 3x square y square. Then x into this is minus x by cube. This is x by cube, but with 3 minus sign, minus 3x by cube. Okay. Then with minus sign, minus this will be negative, this will be positive, minus negative, positive, negative, and 3 multiplied. All these terms are there. Now let me write the denominator. 1 minus twice x by plus y square whole power 5 by 2 now. The same denominator as we are having here. This is also the same denominator. What the numerator here? Let me solve the second part. So finally we get the second part here. Solving with twice x by, is there any term which is similar? And with twice x by is independent here. This we have taken. Now minus 4x square y square. This is plus 3x square y square. Any difference? No. This is minus x square y square here. The difference of these two. This is minus 4x square y square. This is plus 3x square y square. Only one is left with negative sign. Now this is twice x by cube. Okay, this is plus 6x by cube. It will be 8x by cube. Okay, same value by cube. And the this is minus 3x by cube, minus 3x by cube. This is minus 6x by cube. Let me first cancel these. It's 6 negative. This is positive 6x by cube. 6x by cube. This is minus 3x by cube and minus 3x by cube. This cancel. This twice x by cube is left over. Twice x by cube. This one is left over. This we have taken. Now minus 3 by square. Now this 3 by 4 minus 3 by 4 and plus 3 by 4 cancel out. Okay, this 3x square by square we have already taken with this. Minus 3 by square is left. This one. Okay, all the terms have been considered now. This is the numerator here. Divided by 1 minus twice x by plus y square whole power 5 by 2. This is part second. Now this is value of part second here. Let me substitute here. So what is this value? This is twice x by plus and minus x square y square plus twice x by 2 twice x by 2 minus 3y square divided by the same value 1 minus twice x by this y square whole power 5 by 2. Okay, this is value. Okay, so we are left with these two parts. This is the left hand side of the result which we have to obtain. Okay, this is left hand side of equal to 0 side. Okay, now we have proved that this is equal to 0. Now LCM is same. So these numerator are added. So what we see here, let me write again. This implies that this whole equal to minus twice x by plus x square y square minus twice x by cube minus twice x by cube plus 3y square. Okay, then plus sign for LCM is same. These two values are this twice x by minus x square y square plus twice x y cube minus 3y square 3y square 3y square twice x by cube minus twice x by cube. This is plus x square y square. This is minus x square y square minus twice x y. This is plus twice x y. So numerator is 0. Divided by 1 minus twice x by plus y square whole power 5 by 2. This is 0 upon something is 0. 0 upon this value. Okay. Plus y square whole power 5 by 2 equal to 0. This is right hand side here. So right hand side is okay. and put is whole equal to 0. We have proved. So the correction was that this is value 1 minus x square, not 1 minus x whole square. This was the correction here, but the students gave me that this is 1 minus x whole square. Maybe they have obtained from their own sources, but my source. But I have just calculated that this is this line. Okay, this is the 11th question we have proved. Now let me take the 12th question, which is the last one. Question number 12 here. What does it say? Question number 12 is, let me take it. Now, question number 12, what does it say? It says that if u is equal to, if u is equal to s into, okay, this is x square plus y square plus z square, only, okay, only, then to prove that, then to prove, what to prove? Okay, then to prove that del square u upon del x square, del square u upon del y square, okay, del square u upon del z square is equal to 4 into, okay, x square plus y square plus z square into f double dash, okay, x square plus y square plus z square, okay, plus 6 times f dash. This is first time differentiation of x square plus y square plus z square. This we have to prove. Okay, so this is 6 times f dash x square plus y square z square, and this is 4 into x square plus y square z square into f double dash, okay. That is second derivative, this is first derivative. Okay, this we have to prove here that this whole equal to this. What is this? We have to find out second derivative of each type, means with respect to x, with respect to y, with respect to z. Let me differentiate this first equation. Differentiating first with respect to x, y, and z partially or respectively, first with respect to x and with respect to y. Since partially we are doing this, so whenever we differentiate with respect to one variable, others are considered constants. When we are differentiating with respect to x, y and z, we